Alright, time to move on to logarithmic equations now. We've been working with expressions. Equations are just going to have an unknown in it that we need to solve for. And really, when we evaluated expressions, we saw some in there anyway. So, as we progress through these, we definitely need to check our answer. And here's how we're going to check. So, let's say the original statement is something like log base b, and I don't really care what b is, and then there's something, and then is equal to a number. Okay, don't much care about anything other than what is in here. Okay, this inside part of the logarithm has to be a number that is greater than 0. Okay, if it is not, then we're in trouble. Okay, logarithms can only take in positive numbers. Okay, make sure to revisit the definition if needed. Okay, so we just need to check that what is inside the logarithm becomes a positive number. Okay, so here we go. I'm going to do a couple for you, and then I'm going to pause the video and provide the answers to some more, and then there's going to be one that is provided as a quiz question. Okay, state the solution set. Here we go. Alright, so how do we begin? Use the tattoo. Okay, or remember the circle method. Okay, whatever. So this is 16 to the 3/4 is equal to x. Oh boy, that's really hard. Now, can I leave it like that? Well, no. Because this actually simplifies quite nicely. Okay, you can type it in your calculator, or you can remember that this is the 4th root of 16, all cubed, is equal to x, and then, so then this is just going to be 2. Okay, or sorry, 2 to the 3rd, which is 8. I'm sorry. There we go. Okay, now I'd need to go back and check my answer. So x, if I put in 8 inside the logarithm, does that come out to be a positive number? Yep. So I'm going to say the solution set for x is 8. Okay. Alright, so now I'm going to do the one right below it. Okay, I think this could be fun. So again, use the tattoo. Technically, you should isolate the log first. The log is isolated, and then you can use the tattoo. So I'll just note, isolate log first. Okay, that's a note. None of these are set up. We will see some in class where we have to isolate first. So, okay, we have 9 squared is equal to 2x minus 1. Okay, this is 81. 81, and then 82 is equal to 2x, so x is equal to 41. Okay, so again, you can plug it in, double check, and it does work. So here, so you do 41 times 2 is 82, minus 1 is 81, and then 81 is positive, so that's all okay. The solution set for x is 81. Sorry, 41. Alright, so I did a couple. Now I'm going to pause the video and I'm going to say, let's have you do the next 3, so this one, and this one on your own. And then we'll save the last one for the quiz. So I paused the video and wrote out the solutions. In the first one I got 1 over 21. 7 to the minus 1 is equal to 3x, and then 7 to the minus 1 is the same as 1/7, 1 over 21. Okay, and then this one I did check it and it does work. So you put in 1 over 21 and yes, that's fine. The next one is a little bit more interesting. So this, again, you have a base of 10 here that is hidden, but so it'd be 10 to the 2 is equal to x squared minus 15x after you distribute, collecting everything on one side and factoring. Yes, we might have to factor or use the quadratic formula. We get 2 solutions, both of which happen to check. Not always going to be the case. Okay, and the last one, this one is a little confusing and scary, but it's not too bad. You just have to convert it to exponential form twice via the tattoo or the circle method, and I got plus and minus square root of e. Okay, and both of them end up checking because of the square. Okay, so for the last one, I'm going to have you do that in the quiz right about now.